This is the video for angles and lines and transversals. So you have definitions that are posted, and I'm going to let you read through those yourself. I'm going to just scroll through these. So for your transversal is a line that crosses two or more lines, and then you have different type angles. So if you go all the way down, you have vertical angles that are across from one another this way. So 1 and 4, 2 and 3, 5 and 8, 6 and 7. So these lines are parallel and they're crossed by this transversal. You have corresponding angles which are in the same location on both parts, so like 1, 5, 2 and 6, 3 and 7, 4 and 8. You have alternate interior angles, which are opposite sides of the transversal on the inside of the parallel line, so 4 and 5, 3 and 6. Then you also have alternate exterior angles, so that would be 1 and 8, 2 and 7, because it's on the opposite side of the transversal on the outside of the parallel lines. And then vertical angles, I already mentioned. Consecutive interior angles. So consecutive interior angles means that they're on the same side of the line, 3 and 5 and 4 or 6. They're inside the parallel lines and they're consecutive, meaning next to one another, and they add up to 180 degrees. So you have theorems basically, which I didn't call them theorems on the notes, but I said if two parallel lines are cut by a transversal, then the following are true. The corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary, which means they add up to 180 degrees. Two lines cut by a transversal are parallel if at least one of the following is true. So if any of these are true, if you're given two lines that are cut by a transversal, if any of these things are true, then they have to be parallel, making all of them therefore true. So that's basically, this is like a theorem. Each one of these is their own theorem, but I just did it as a group. So just with that in mind, we're going to do a few examples. And I don't have the examples added on here because it's sometimes it's hard to draw this on the computer. So I'm just going to show you here. Okay, so we have in the figure, P is parallel to Q. So this is line P and this is line Q. The measure, and you've got these angles, the measure of angle 1 is 107 and 11 is 48, and find the measure of each angle. So you've got P is parallel to Q. I didn't make it very parallel. I'm not great at drawing, but they're cut by a transversal. You've got this one transversal goes this way and another transversal goes that way. So it says the measure of angle 1, let me get a different color. The measure of angle 1 is 107 degrees. So that's 107, and it also tells you the measure of angle 11 is 48 degrees. So that is 48. So if we look at these angles here first, because we've got these parallel lines cut by this transversal, so we're going to ignore this for just a second. So 1 and 7 are vertical angles. That means they have to be congruent. So you can start there if that's where you want to start, that's fine. You could also do corresponding angles. 1 and 3 are corresponding. They're in the same location, just on different lines. So they have to be congruent. You could start with 1 and 2 form a line, meaning they have to add up to 180 degrees. So you can pick, there's lots of places to start. So I'm going to do vertical angles first. So 1 and 7 are vertical angles, meaning they're congruent. So 7 also has to be 107 degrees. Well, so now 1 and 2 are on the same line, so they have to add up to 180 degrees. So if I take 180 degrees and subtract 107 or you could do 2 and 7 as well, because see now these have to add up to 180 degrees because they're also on the same line. But anyways, so 180 degrees minus 107 should be 73. So this would be 73 degrees. And I'm going to write down here the measure of angle 2 is 73 degrees, and that's because these are a linear pair, meaning they add up to 180 degrees. So, okay. And then I can use the fact that 2 and 8 are vertical angles, or I could use the fact that 1 and 8 are linear pairs, or 7 and 8 are linear pairs, however you want to think about it. But regardless of how you think about it, angle 8 then would have to be also 73 degrees. I don't have enough room, so I'm going to do this. Okay, so vertical angles or linear pairs. So there I've got those 4 filled in. So then to move to this side, I already mentioned you could start here. 1 and 3 are corresponding angles, so they have to be the same. But now also, if you look at it, this is the interior, so here's your 2 parallel lines. So these are the interior. So your alternate interior have to be equal, seeing as how these are parallel lines. So alternate interior angles have to be the same. So go to the opposite sides on the inside. So 3 would have to be 107 and 6 would have to be 73. So if you wanted to do alternate interior angles, you could, or you could also, like I said, do corresponding. So corresponding 1 corresponds with 3, so they would have to be 107. 8 corresponds with 6, so that would have to be 73. So however you wanted to think about that. Same is true for 4 and 5. So now 3 and 4 are a linear pair. 6 and 5 are a linear pair. They have to add up to 180 degrees. Also true, 2 and 4 is corresponding angles. They have to be the same. 7 and 5 is corresponding angles. They would have to be the same. Or these are on the outside. These angles are on the outside of your parallel lines. So you could do alternate exterior angles. So 8 and 4 are alternate exterior. They would have to be the same. 1 and 5 are alternate exterior. They would have to be the same. So however you want to think about it, or again, you could do vertical angles. So 6 and 4 would have to be the same, and 3 and 5 would have to be the same. So there's lots of ways to come up with that those are 107 and 73, 4 is 73 and 5 is 107. Lots of different ways to figure out or to give reasons as to why that is. So for measure of angle 3 is 107. I'm going to put, I'll just do corresponding with angle 1 for that one. Okay, measure of angle 4 is 73. And again, you could do linear pair with 3, or you can do corresponding with angle 2, whatever you want to. Whichever one you want to do. Measure of angle 5 is 107. And again, that's either corresponding with 7 or a linear pair with 5, or a vertical angle with 3. For that one, if you have to give a reason, you can pick one. You don't have to list them all necessarily, but let's do vertical angle with angle 3. And then measure of angle 6 is 73. And again, we'll put vertical angle. I forgot my degree sign on these. I'll just put vertical angle with, try to make it faster here, angle 4. Okay, angle 7 is 107. And again, that was vertical angle with 1. And measure of angle 8 is 73. And that was a vertical angle with 2. Or like I said, on some of those, let me do with angle 2. Try to make the video a little bit shorter. Some of these you could also do alternate interior or alternate exterior as well if you chose to, if you prefer those reasons. Like I said, if it asks you to give a reason, you don't have to list all the reasons. You can just pick one. Okay, so now for the bottom part here, it tells us, so now this part we're going to ignore this top line basically. So we just ignore that. So this bottom one, it tells us measure of angle 11 is 48. Okay, so that was given to us. So then we've got to figure out the rest of them. So again, we have vertical angles here, 11 and 13 are vertical angles. They have to be equal. So I'm going to say this is 48. The measure, and then if you want to fill in all the 48s, 11 and 15 are alternate interior angles. So 15 would have to be 48. 13 and 9 would have to be alternate exterior angles, so they would have to be the same. So 9 would have to be 48, if you want to go ahead and do those. And then fill in the other numbers. 11 and 12, or 12 and 13, either one, they're a linear pair, so they have to add up to 180 degrees. So if I take 180 degrees minus 48, I should get 132. And then 12 and 14 are vertical, or again, these are linear pairs and these are linear pairs, so they have to add up to 180. So that would be 132. And then I can fill in 10 and 16 as well using linear pairs, or 10 and 14 are alternate interior angles. So 10 is 132, 16 and 12 are alternate exterior angles. They're on the outside of the parallel lines, so that would be 132. Or I could have also used corresponding. 12 and 10 corresponds, 13 and 15 corresponds, 11 and 9 and 14 and 16 corresponds. So several different reasons, again, just like for the first one, that you can choose which one you want to. Measure of angle 9 is 48 degrees. And this time I'm going to put alternate exterior angles with 13. So alternate exterior angle with angle 13. So they have to be congruent. Measure of angle 10 is 132. And we'll put this time alternate interior angle with 14 because I figured them out in reverse order, but that's okay. With angle, not with 14, sorry. 10 and 14 are alternate interior angles. 11 was given to us, so the measure of angle 12 is 132, and that was because it was a linear pair with 11. So they had to add up to 180 degrees. I forgot to put with angle 11. And then 12, 13 is 48. And that was, 11 was given to us, and so we said vertical angles are equal. So vertical angles, vertical angle with angle 11. I ran out of room, so let me write over here. Measure of angle 14 is 132. And I think, again, we can say it's vertical with 12, or we can say it's alternate interior with 10, whichever one. I put 10 as alternate interior with 14, so that's fine. I'll just put vertical with 12 for this one. Like I said, there's several reasons for each one as to why they are what they are. And then 15 is 48, and 16, 48 degrees. 15 is 48, it's alternate interior with 11. Alternate interior with angle 11, so they have to be the same. And then last, 16 is 132. And it is, let me do an, I don't think I wrote down, oh no, I did write down alternate exterior. I'll write down alternate exterior again. 16 and 12 are alternate exterior, so we can use that reason. Or like I said, you could use vertical with 10 or corresponding with 14, or, you know, like whatever reason. So if you have to do something like this for homework, you'll just pick a reason and go with it. You don't have to list them all, kind of like what I've done. I've told you there's several reasons and mentioned each one, but you can just pick one to write down. Okay, so that's all these angle measurements for, since P and Q were parallel and they were cut by these two transversals. So you fill in the first ones up here first and ignore the other ones, and then do these down here. Okay, so we want to, on number 2 here, we want to find X and Y. So you're given this triangle, and it's got these two lines. It's got, this is the base of the triangle, and then it's got another line drawn in the middle of it, and it's got these angles, and it wants you to find X and Y. Well, so these two lines, it tells you are parallel. So like if you dot these out, then we have two parallel lines, and they're cut by a transversal. They're cut by this transversal here that goes this way. They'll also be cut by this transversal here that goes this way, but we're focusing on the one that goes this way. Okay, so if we just kind of ignore this for 1 second, you've got these two parallel lines cut by this transversal. That means all that stuff's true. The alternate interior angles are equal, the corresponding angles are equal. I didn't mention consecutive interior angles on the other one. On this one, consecutive interior angles, so like 7 and 6 are next to one another and they're inside, so they also have to add up to 180 degrees. I feel like consecutive interior angles is one that people don't use quite as much. So 107 and 73 do add up to 180. Same thing for here. This down here, 10 and 11 are consecutive. They're next to each other, interior, and they're both on the inside, so they also have to add up to 180 degrees. So 132 and 48 add up to 180 degrees. So here and here, you have, these are considered consecutive interior angles, 3x plus 11 and 3y plus 1. So they would have to add up to 180 degrees. Well, that's fine, but this one's y and this one's x, so I can't do that yet, okay? So if I look here, this angle is 4x minus 5. So these are corresponding angles. So 3x plus 11 would have to be the same thing as 4x minus 5 because they're corresponding angles. Again, if you ignore all this. So those two parallel lines are cut by that transversal. Those two angles correspond. They have to be the same. So I would have 3x or 4x minus 5 has to equal 3x plus 11 because they're corresponding angles. So corresponding angles have to be the same. Oops, camera went blurry. There it goes. Okay, so now I just have this equation to solve. So I'm going to subtract 3x on both sides, and I can add 5 to both sides. So I get 4x minus 3x is x. The 5's cancel, so I get x equals, these cancel, 11 plus 5 is 16. Okay, so I know x is 16, so that's one thing I was supposed to find. I had to find x, but I also need to find y. So in order to find y, it doesn't tell you to actually find these angles, but in order to find y, I need to know what this angle is because, or this angle, either one. These are a linear pair, they have to add up to 180 degrees, or these are consecutive interior angles, they have to add up to 180 degrees. So either one, which if I know one, I know the other because they have to be the same because they're corresponding angles. So whichever one I choose to solve for, they're going to be equal. So if I do, let's see, we do this one. So if I do 4x minus 5, so 4 times 16 minus 5, I should get 59, I think. I should get 59. Yeah. And then also true, if I do 3x plus 11, I also get 59. So 3 times 16. I did check that on my calculator. I had it wrote down, but I didn't trust myself. 3 times 16 plus 11 is 59. So these angles here both are 59 degrees. So let me write, I'm going to put 59 degrees here and 59 degrees here. Because they have to be equal because they're corresponding. So now I can figure out what my y is. So again, either using consecutive interior angles or the fact that these are a linear pair. Either way, they have to add up to 180 degrees. So 3y plus 1 has to equal 59 degrees. Or not equal to 59 degrees. 3y plus 1 plus 59 degrees has to equal 180 degrees because these are a linear pair and these are consecutive interior angles. So if I do 3y plus 1 plus 59, I have to get 180 degrees. And like I said, because of linear pair or consecutive interior angles. So if I solve this, I have 3y plus 60 equals 180 degrees. If I subtract 60 on both sides, I get 3y equals 120. And divide by 3, I get y is equal to 40. And there's my answer. Y is 40. Okay, so that would be all for that problem. And again, you're just using the fact that these two lines in this triangle are cut by this transversal, and we used corresponding angles and then that are equivalent or consecutive interior angles or a linear pair that have to add up to 180. Okay, for our last problem here, is P parallel to Q? That's the question, and you have to answer it. It doesn't tell you to specifically prove it. If you wrote a proof for this, it would be fairly simple because you could use the like what I said on the notes that wasn't theorems, but I mean they are theorems. I just didn't call them theorems, but it doesn't ask you to prove it. It just says are they. So is P parallel to Q? So for this one, we have to check, you have to check, as long as at least one thing has to be true. So corresponding angles would have to be the same, alternate interior angles are the same, alternate exterior angles are the same. But if you look back at the notes, my computer locked down. If you look back at the notes, it says if at least one of the following is true, then they are parallel, because if at least one's true, then they all have to be true. So if you check this one, 115, these are corresponding, 65's corresponding. They're all congruent. All these corresponding angles are congruent. Alternate interior angles, so if I go this way, if I make an X on the inside, they're the same. If I do alternate exterior angles, they're the same. So that's all true. The consecutive interior angles are supplementary, meaning they add up to 180 degrees, so that's also true. So since all of those things are true, then we can say yes. And like I said, we just had to use one of those, because if one of those is true, they would all be true. The vertical angles is true, but that doesn't help you because that's only dealing with one line. So you have to check one of the others because you got to deal with both lines to make sure they're parallel. The vertical angle thing is true, you know, always like this. But so we have to check for corresponding consecutive or add up to 180 degrees, or the alternate interior or exterior. So we'll say yes, they are parallel, and like I said, you can pick one. So I'm going to say I'll pick alternate exterior angles are congruent. And so if you were actually writing a proof, that would be pretty much your proof, like because you only need that one theorem, because it's true if at least one of those is true. So you only need the one thing to say, but so this will be a simple, straightforward proof, but we don't actually have to write the proof. And then for the second one, it shows you P and Q, and it's cut by this transversal, and it says 95 and 100. So are these parallel? Well, in order for them to be parallel, alternate interior angles have to be congruent, so this would be no, because the alternate interior angles are not congruent. And again, you could use vertical angles to find these other angles, but that still doesn't help you, because if you do vertical angles, that's just for one line, so you have to do both lines to compare, to look at to see if they're parallel or not. Okay, so that is it for transversals and angles. If you have any questions on any of that, please send me a message.